Hey guys, Miss Hybert here. Ready for a quick math lesson? Great. Okay, today is going to be a neat one. We're going to be working with line plots, as you can see down here. And we're going to be working with mixed numbers and whole numbers and adding and subtracting those mixed numbers, okay? So let's just go ahead and jump right in and read by reading the directions, okay? So read this with me. The Right Stuff, a stationery store, sells a variety of different sized envelopes for business and personal correspondence. The heights and lengths of the envelopes are given in the tables below. All measurements are in inches. Okay, important stuff there. These numbers represent inches, right? And we've got the heights and the lengths. So we've got a business table, height in inches, length in inches, and a personal table with the height in inches and the length in inches. All right, let's take a look at what it's asking us to do. We need to plot the heights of all the business and personal envelopes on the line plot below. Okay, I noticed something super important there. It's asking us to plot just the heights. You're right. Oh my goodness. So these lengths, do they even matter? Not really in this section of our work, right? So when we are plotting the data, we're just going to focus on the height in this table and the heights in that table, okay? So let's give our line plot a title. Well, I know that height is important here. So since it's measuring envelope heights, I think that'd be a great title for this graph. So you can title your graph Envelope Heights. Now this bottom line here is always a title that tells the reader what the data you're taking is or what the units of that data are, okay? So this is measuring. What is this measuring? What are these numbers? Yeah, you're right. It's the height in inches. So that would be a really good way to label this bottom part. Would be height in inches. So that tells what our units are too. Very important. All right, now we're ready to start plotting. Now I want us to take a look at the line plot so we'll be able to easily read this. Remember a couple of math lessons ago, we looked at a ruler and we looked at all those tick marks in between a ruler and what each of those tick marks in between really stood for. And they were usually eighths, sometimes 16ths on your rulers, and somewhere you could see like the fourths. So this is kind of how our line plot is broken down as well, okay? It's like a ruler. So we're gonna have to think of it that way as we add our data, okay? So if you look at each little tick mark, it is really an eighth. So I'm gonna label them here and I want you to look with me. So this next tick mark after the 3 would be, now I don't have a ton of room, so I'm gonna it would be 3 1/8, but just for room's sake, I'm gonna write 1/8. Oh, I need a pen. Okay, so it would be like this. This would be whole number 3. Then this next would be 3 1/8. Then this next one would be like 3 2/8. 3 3/8. Now this says 3 1/2. But remember, 4/8 is the same thing as 1/2. Okay? So this next tick mark would be like 3 5/8. Then the next one would be like 3 6/8. 3 7/8. And then 8/8 would be a whole number, so that would give you 4, okay? So that might kind of help you visualize how we're going to plot things. I also want to draw this little diagram here. That might help you see things a little clearly too. Feel free to draw along with me if you'd like on a scrap sheet of paper. So I'm starting out with a big rectangle that represents one whole, right? Like think of this as like 1 whole inch. So here is like 0 inches. here's like 1 inch, okay? So all together, this whole thing is 1 hole. Now, if I took my 1 inch and put a line right down the middle, that would be 1/2, wouldn't it? My 1/2 mark. Okay, now if I just look at these like 2 rectangles now, and I take this, look at this first rectangle shape and divide it in half here, and then divide the other rectangle in half here. Now I've broken up my 1 inch into fourths. See, there's 4 squares now. Let me grab my laser. 1, 2, 3, 4. Okay, so that yellow mark is like representing my fourths. So there's 1/4 here, 2/4, which is the same as 1/2, 3/4, 4/4, which equal a whole, right? Now let's split it up even more. If I look at these squares and I take this, look at this first square I have here and divide that first square in half, now I have my eighths. So I go and divide all my little squares in half, and now I've got eighths. So this blue line, or these blue marks, represent my eighths. So there's 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, and 1/8. Now remember, here is my fourth mark. There's my 1/4. Okay, then like this would be 2/4 is equal to 1/2. Okay, now let's take a look at this too. How many eighths does it take to get to 1/4? Yeah, so there's 2 eighths are equal to 1/4. Now, how many eighths does it take to get to a half? Count them. 1, 2, 3, 4. Oh my goodness. So it takes 4 eighths to get to a half. So 2/4, 1/2, and 4/8 are all equivalent fractions, okay? Now, what about your 3/4? So there's 3/4, right? There's 1/4, 2/4, 3/4 would be right there. How many eighths does it take to get to 3/4? What is 3/4 equivalent to in eighths? Let's count. 1, 2, 3, 4, 5, 6. 6 eighths equals 3/4. Okay, those are examples of some equivalent fractions that we might run into, okay? Now, if I look at my data sets, I've got halves, I've got eighths, and I've got fourths. I've got a few whole numbers in there too. But we're going to be measuring to like the nearest eighth of an inch, since there are 8 spaces until you get to the next whole number. So like if we started here at 4 inches, let's see how many spaces there are till we get to 5 inches. 1, 2, 3, 4, 5, 6, 7, 8. So this is divided up into eighths. So we're going to have to measure to the nearest eighth, because guess what? Some of these might not work out in the most equivalent way, and I'm going to show you what I mean as we go on, okay? So let's get started. The first one is pretty easy. Now, we're going to refer back to our little picture here a lot, so I hope that helps you, and I hope labeling some of these down here help too, but you don't have to label every single one down here. It's just kind of a way to visualize it a little bit more, but as we go on, I think you're going to get the hang of this right away, okay? Let's get started. We've got 3.5. All right, I can see that right away on my line plot. That's going to be really easy to add. I'm going to just put an X right there over 3.5 and mark it off. All right, now next we need to go to 3 5/8. Well, look at our little handy dandy labeling we did down here. We know that 3 5/8 would be right here. I have my little 5/8 labeled. So take your pencil and make an X there for 3 5/8. eighths. Now, if you think about it, you know that 3 1/2, you know that 4/8, look back at our little picture here. 4/8 is the same thing as 1/2. So that's how I knew 5/8 would be the next tick mark up. Okay, does that make sense? Good. All right, the next one is a freebie because it's 3 5/8 again. We know exactly where that goes. Plot it on your graph and mark it off up there. Okay, now let's take a look at the next mixed number. We've got 3 3/4. Okay, do you guys see a 3/4 down here? No, we're going to have to think of what will be the nearest equivalent fraction to that. Now, if you look on our little graph, I do see a 3/4 here. And in eighths, we know that there's something that's equal to that. What is 3/4? What is the fraction 3/4 equivalent to if you break it down into eighths? You're right, 6/8. So to find a place for 3 3/4, would it be okay to put it at 3 inches and 6/8? 3 6/8 inch, is that the same thing as 3 3/4 of an inch? It sure is, because we know that 6/8 is equivalent to 3/4. So we need to find where 3 6/8 would be on our line plot, and that's easy since we kind of already numbered it off. So 3 3/4 would go, everybody watch me where I put this one at, go right here. That's where 3 3/4 of an inch belongs. Once you've got that plotted, mark it off. All right, now we can go to the next mixed number on our list, and that is 3 7/8. Take a look at our line plot. Is there a place where you see a 7/8? Yeah, 3 7/8 belongs right here. Make an X, mark it off. All right, are you ready to move to the next one? Because it's a freebie. It's another 3 7/8. I know exactly where that goes. All right, once you've got it plotted, mark it off. Okay, hopefully you're keeping up with me just fine. Let's take a look at the next number in our data set. That's whole number 4. That's super easy. I see it right there looking at me. 4 inches belongs right here over the 4. Got it? Mark it off. All right, so the next number on our data set is 4 1/8 of an inch. And just like we went and labeled all the little tick marks in between our 3 to 4 inches, it's the same thing for in between 4 and 5 inches and in between 5 and 6 inches. So this next tick mark, we know this is 4 inches, right? This next tick mark would be 4 1/8, 4 2/8, 4 3/8, 4 4/8, right? And so on. So we know exactly where 4 1/8 would go. It would go right after whole number 4. So we can add 4 1/8 on our line plot right here. Once you've got that marked on your line plot, mark it off right there. All right, ready for the next one? Good, the next number is 4 1/2. I can see it right there looking at me. So I know 4 1/2 belongs right here. Once you've added it to your plot, mark it off. 4 3/4. Okay, remember, look back at our little chart we drew, our handy dandy rectangle, fraction bar, whatever you want to call it. We know that 3/4 is equivalent to 6/8. And since this is broken down into eighths, we need to find 4 6/8 because that is equivalent to 4 3/4. Here, 4 6/8 is the same thing as 4 3/4. All right, so if you have 4 1/2, which is 4 4/8, keep going up. So this is 4 4/8, 4 5/8, 4 6/8 belongs right there. Okay, so that's where you're going to make your X for 4 6/8. Got it? All right, so once you have that plotted on your line plot, mark it off, and we're ready to move on to the next number. All right, the next number in our list is whole number 5. That's easy. It goes right here. Once you've got it on your line plot, mark it off on your chart. Oh, another whole number. Those make my life so easy. Whole number 6, mark it off. Add it to your chart. Good. You guys are sticking right with me. Way to go. Now, we're already done with the business side. Let's add these personal envelope measurements. All right, our next envelope measurement is 3 5/8. Okay, let's take a look at that. We know where 3 5/8 belongs because we've already kind of drawn it out. Here's our 3 inches. Keep going up until we get to 5/8. There's 3 5/8. So that's 1 tick mark after 3 1/2. So your 3 5/8, we're going to add another one to that, and it goes right there. Got it? Once you've got it plotted, mark it off. Let's take a look at our next number on our list. We've got 4 3/8. So let's go to whole number 4 and count up tick marks till you get to 3/8. Okay, so there's 4. 4 1/8 would be here, 4 2/8 would be here, and 4 3/8 would be right here, right before you get to 4 1/2, okay? So that's where 4 3/8 belongs. Add your X, mark it off your list. All right, we're moving right along, guys. Let's take a look at the next number. We've got 4 3/4. Let's take a handy look at our handy dandy fractions bar over here. We know that 3/4 is equal to 6/8, and since this is broken down into eighths, we can find, here, let me grab my pen. We can find 4 6/8 instead, right? It's equivalent. It's the same fraction, okay? They equal each other. So if you go to 4 1/2, remember 4 1/2, that's 4/8. 1/2 is equal to 4/8. So there's 4 4/8, 4 5/8, 4 6/8 would be right there. So we've got another little X to add over that one, okay? So here's where your 4 3/4 or 4 6/8, they're equivalent. That's where they belong. So once you've got that marked on your line plot, you can go ahead and mark it off your list. And we're ready to move on to the next number. We're almost done, guys. The next number is 5 1/4. Again, let's take a look at our handy dandy little fraction bar. We know that 1/4 is equal to 2/8. So if we count up by eighths till we get to 2/8, we know that we're putting 5 1/4 in the correct spot because 5 1/4 is equal to 5 2/8. It's an equivalent fraction. So this is 5 inches. This next one would be 5 1/8. We're looking for 5 2/8, so that's where we're going to plot our 5 1/4. It's going to go right here. So make your mark and mark it off your list. All right, next number, we've got 5 1/2. That one's easy. I see it right here. I'm going to add it to my line plot and mark it off. Okay, the next one is 5 3/4. Well, if we look again at our handy dandy little fraction bar that we drew over here, we know that 3/4 is equal to 6/8. So since this is broken up into eighths, we just need to count up until we get to 5 6/8 because we know that 5 6/8 is equal to 5 3/4, right? All right, let's do that. So this is, we also know that 5 1/2 is equal to 5 4/8. So there's 5 4/8, 5 5/8, 5 6/8 would be right here. So that's where we can make our mark for 5 3/4. Okay, and then we're almost done. One more number, and it's number 6. So easy. add that to your line plot, and we are finito. That's Italian for finished. All right, so make sure you have your graph looking just like mine. It can get a little confusing when you're having to think about eighths and fourths and halves, but hopefully having this little diagram and knowing your benchmark fractions and being able to visualize what those benchmark fractions look like helps you get through this. So let's take a look at some of the questions on the next page, Math Journal page 287. All right, now that I have you guys on page 287 with me, remember I said we were going to have to be adding and subtracting some mixed numbers here today. Now, since our data is broken down really easy for you to see it, you will be able to answer these types of questions really quickly just because you are able to read a graph, right? So you'll be able to really easily point out the largest, the smallest, which envelope has the most, and those kind of things you're going to be able to really easily see in your graph. That's why graphs are important. It's like a good way to organize data to be able to quickly find information like that. Now take a look at this next question, question number 4. What is the difference between the largest and smallest heights? Well, we know that difference means to subtract. You're right. So we're going to look at our graph, and we can easily see that the smallest fraction in our graph is 3.5, and the largest is 6. So we will need to set up a subtraction problem, right? So your subtraction problem will need to have the biggest number on top and the smallest number on the bottom. Now, follow along with me as I do this subtraction problem. 6 minus 3.5. Well, when you are subtracting a fraction by a whole number, you're going to want to give that whole number a fraction to go with it. So I gave this whole number 6 a fraction. I gave it 0 halves. Okay, so it still is equivalent to just whole number 6, but to keep us in the right place and to make things less confusing, give it the fraction of 0 halves. Okay, I chose halves because this already has 3.5 already has 2 as a denominator, so I just kept it the same. Okay, so when you're setting up your subtraction problem, go ahead and write it the same way. Now, we're ready to subtract, but can you take away 0 from 1? No, you can't. So remember, we did a lot of these back toward the beginning of the year where we had to borrow when we subtracted. So I'm going to show you again how that's done. All right, you can't take away 0 from 1. So you need to borrow a whole number from there, from your 6 here. So mark out that 6. That 6 is going to become a 5, but you have to do something with that one whole. Okay, so how can we represent one whole when your denominator is 2? You're right. 2 halves would make a whole, right? So you're going to have to add that to your fraction that you have here. What is 2 halves? What is 0 plus 2? You're right, it's 2. And what do you do to the denominator? You keep it the same. Okay, now we have a new fraction to work with here. We've got 5 and 2 halves minus 3 and 1/2. So now we're ready to subtract, okay? So I'll write it one more time so it's nice and clear and easy to see. That changes into 5 and 2 halves minus 3 and 1/2. Now we are set up for success and ready to subtract, okay? So can you take away 2 from 1? Yep, that gives you 1. Denominator stays the same. Okay, now you can take away your whole numbers. 5 minus 3 is 2. You're right, and there's your answer, 2.5. So what is the difference between the largest and smallest heights? 2.5 inches. Simple as that, okay? So when you're subtracting, don't forget how to borrow from that whole number, and it'll be a piece of cake, okay? All right, there's one more that I want to do with you just for good practice, okay? So let's take a look at number 5. So number 5 says, in the United States, the most popular business envelope is 4 1/8 of an inch by 9.5 inches. It is called the standard number 10 envelope, okay? But I want us to take a look at question 5C together. Okay, so everybody get with me on question 5C. So question 5C asks, how much larger is the height of the number 10 envelope, which is this guy up here, than the smallest one sold? So we are going to have to look back at our line chart, and you can see on our line chart that the smallest envelope that is sold is 3.5 inches in height. So asking how much larger is a subtraction problem, right? So we're going to have to do subtracting the number 10 envelope. So what is the height of the number 10 envelope? 4. Whoops. Let me go back. The height of a number 10 envelope is 4 1/8 inch, right? And then what was, so we're gonna have to minus that. And then what was the smallest envelope sold? Look back at your line chart or your line plot. Yeah, you're right, 3.5. So this is the equation that we need to solve. Everybody take a look at this. 4 1/8 of an inch minus 3.5 inches. What do you notice? Oh yeah, I noticed that the denominators are not the same. We can't do it if they're not the same. So we're going to have to apply what we know about fractions to make one of these denominators the same. Now, since it's much easier to change 2 to 8 instead of changing 8 to 2, I'm going to focus on taking 3.5 and finding an equivalent fraction that would also end in an 8. So I'm going to take this 3.5 and change it to where it will have a fraction with a denominator of 8, and then I'm going to subtract. So watch how I do this, okay? Remember, the twin way is a way that we can get equivalent fractions. So remember what the twin way is. Whatever you do to Sarah, you got to do to Anna. Whatever you do to Isabel, you got to do to Maria, right? So what can we do to 2 to get it to 8? What can we multiply by 2 that would equal 8? 4, you're right. So watch this. I'm going to take my 3.5 and I'm going to change it to where I have a denominator that ends in 8. Okay, so got 3.5. And you guys said I needed to times it by 4 to get to 8. Okay, that makes sense. So whatever you do to Sarah, times by 4, you got to do to Anna, times by 4. So now I have 3, and then what is 1 times 4? 4, you're right. And then what is 2 times 4? 8. Good. Now I have 3 4/8. That is the same thing as 3.5. So if I do 4 1/8 minus 3 4/8, I will be good to go. So that is what I'm going to do to solve problem 5C. So do this along with me on a scrap sheet of paper. I've got 4 1/8 minus 3 4/8. So remember, set it up like this. Your bigger fraction has to be on top. The smaller fraction has to be on the bottom. Okay, now we're ready to subtract. Can you take away 1 from 4? No, you can't. We've got to borrow again, just like we did up here. Okay, so follow along with me. All right, you can take away 1 from 4. So mark out this 4. make it a 3. We got to put that whole number somewhere that we just borrowed, so let's add it over here to this little fraction. All right, if my denominator is 8, how can I represent 1 whole? Yes, 8 eighths. Good job. All right, let's add that to get our new fraction. 1 plus 8 is 9. Very good. And keep your denominator the same as an 8. All right, now we've got a new fraction. We've got 3 and 9/8 minus 3 and 4/8. Okay, so ask yourself, what's 9 minus 4? 5. You're right. Keep the denominator the same. It's an 8, and then 3 minus 3 is 0. So what are we left with? Just 5/8. Yes, so the answer for 5C is 5/8 of an inch. Okay, that was a lot, but I hope it helps you get started with this lesson. And if you have any other questions, you can always feel free to remind at me, email me, leave a question in the comments, and I'll get back to you as soon as I can, okay? So I hope this helps you get off to a good start and you have fun finishing up the rest of this math journal page, okay? I'm going to give you some good news. You do not have to do math journal page 288. So once you finish pages 286 and 287, you are done for the day because you've already done page 285, right? We did 286 together, and I helped you with a bunch of questions on page 287. So once you've done page 285, 286, 287, you're done. An easy, quick math day. I hope you learned lots from this, and it's always good to practice some things that we've learned before because remember, we have done this type of math equation before. So I know you can do it, okay? So just keep applying what you know and keep practicing what you know, okay, guys? I will talk to you soon. Have a great rest of your day. Remember to like and subscribe. I'll talk to you later. Bye.